So limits at infinity happens at vertical asymptote. And by that, looking at it visually, let's go ahead and make our vertical asymptote. It's not there, but you can go ahead and use any color you want and make your vertical asymptote. And this one is at x equals 2. Okay, I'm going to show you visually first and then look at it algebraically, okay? So looking at this, let's go ahead and draw the arrow, even though it's not on there. We know where it's trying to point to. So given the vertical asymptote at x equals 2, to the right, it is reaching positive infinity, and to the left, it is reaching what? Negative infinity. So the limit as x approaches 2 from the left, it is reaching negative infinity. From the right, it is also, it is reaching infinity. Now, mathematically, here's the way I want you guys to think of. So off to the side, somewhere on the top, let's write something. If you have any number, and that any number could be as small as 1, over a very small negative number, a very, very small decimal number, will always give you negative infinity. In the other direction, if I give you any number, it could be as small as 1 again, and a very positive, small positive decimal will always give you what? Positive infinity. And if you want to test it out with a calculator, you can, but I think you guys have a good math background, shouldn't be a problem. So let's apply that on this one. We have, if I were to plug in 2 from the left, that means I have 3 all over. What number is directly to the left of 2? A very small decimal. 1.99999, right? Let's plug that in. 1.99999, how many ever you want. So that's going to give us some number divided by a very small negative number. And that rule applies to the first one, which leads us to negative infinity. Are we okay with that concept? Okay? Now let's go to the second one. Now I want a very, very, very small number of 2, but directly to the right of it. So in this case, I have 3 all over, probably 2.0001. Add as many zeros as you want, minus 2. So that's going to give us 3 divided by a very small positive decimal. And that rule applies to the second one, so it's going to give us infinity. So if you want to see it visually, there it is. Mathematically, here it is, but the visual will not always be provided for you. Okay? So let's go ahead and read these two to your neighbor. Let's read.
It's so you. On the contrary, it tells you how to pull it off.
All right, so let's go ahead and conclude here. Off to the side. If you have a number divided by 0, that tells me the limit does not exist, which also allows me to know that there's a vertical asymptote, meaning it could be infinite or negative infinite limit. That's all that it's trying to say. So on number 1, Jaden, let's read.
Determine the limit of each function as x approaches 1 from the left and from the right. Answers could be D and E, but let's practice determining whether the one-sided limit is infinity or negative infinity.
So it'll be from the left, from the right, and I want to mainly focus on these two. Because I know does not exist mean it could be infinite or negative infinity, but let's be very specific on this one. So it says limit as x approaches the one from the left side. So the number that's directly to the left, what decimal value would that represent? Less than 1 is 0.999, how many ever you want, right? Minus a 1. So we have some number divided by a very small positive or negative. Very small negative. And that tells me we have a what? Negative infinity. For the next one, it says the limit as x approaches the 1 from the right side. So that's going to give us 1 over 1 point what kind? 0, 0, as many 0, 0, 1, minus a 1. So we have some number over a very small, what kind? Positive. And that's going to lead us to what kind of infinity? Positive infinity. So with the partner, I want you to go ahead and do B, C, and D. And C and D, use the graph.
You C and D and B?
Mm-hmm. Bless you.
The square just makes it negative.
What do you mean? No, make it positive.
Yes, ma'am?
For B, did you get 1
That's not updated.
plus 2?
Which one? The HOCO? Update it. Yeah, change it.
What's the, how did you get the box with it?
All right, check with mine on the board. Hopefully the one with the graph is easier, right?
Yeah.
Okay, I'm gonna explain why part B is making it go in the same direction. No matter what number all squared, whether it's positive or negative, will always be a positive.
Yes.
So Evan, let's read the bottom. If,
f of x approaches infinity or negative infinity, as x approaches c from the left or the right, then the line x equals c is a blank of the graph of f of x.
so that line would be a vertical asymptote. You gonna write it down?
Yeah,
Did you write vertical?
I didn't know, I'm processing.
Okay. 2 letters. Okay. Okay, let's go to the next page.
Still,
On the next page, it's gonna sound kind of like algebra 2, because y'all remember finding vertical asymptotes and holes? Y'all remember Frady?
what?
No? No Frady? Okay.
Brady.
All right, I'll give you some reminders from the Frady. It's when graphing rational functions. All right, it says to find all vertical asymptotes. Vertical asymptotes always come from the bottom. So in this case, the first thing I want you to do is completely factor out. Notice the 2 is already out there, but do we notice this right here is difference of 2 squares?
Yep.
So we have x minus 1 and x plus 1. And your vertical asymptotes will always come from the denominator. So in that case, my denominator has 2 factors already done for us. Of course, you would have to solve for it. So if I set x minus 1 equal to 0, what would the first vertical asymptote land? 1. X equals 1. The second one is going to be n? Negative 1. And make sure you write it as an equation. It is a line. Asymptote is a line. Okay, let's go on to C. On C, the first thing we should again do is what? Factor. And these have understood 1 in front of the x squares, so let's do 1 go. So for the top, what 2 numbers would satisfy the product of negative 15 and the sum of 2? 3 and 5. What kind of 3?
Negative.
Negative 3. Okay, what about the bottom?
5 and 2,
5 and 2? Are they both positive or one negative?
both positive.
Both positive. And we notice something eliminates, right? When something is eliminated, that is a hole. So let's write off to the side. There is a hole.
That,
Did I cross off the wrong one? Oh, silly me. I know. How dare I make a mistake?
Whiteout's a great thing, though.
What's that?
Whiteout is a great thing, though.
I know. If only all your mistakes could be like just white it out, right?
Observation.
Okay. All right, let's cross off the right one. Okay, y'all remember or do you know another word that's representing whole? It might be a calculus word, but in case you might know.
Isn't it like discontinuity? I don't know how I knew that. but-
Removable discontinuity. Remember this word. Know this phrase, because I may use this phrase instead of whole. So if I give you a whole, it's the same thing as removable discontinuity. So that is at. If I solve for x, that's going to give me x equals -5. Let's also find the vertical asymptote. For my vertical asymptote, since that's eliminated, do I have 2 vertical asymptote or 1?
One.
Just 1. So I know that's going to be at, why that I don't know, at x equals -2. Let's say that is at. All right,
So what would you do with the x minus 3?
that will be an x-intercept, but that's not one of the ones that we're asking for. Okay? All right, Avery, let's read the recap part.
A vertical asymptote is a non-removable discontinuity, and a hole is a removable discontinuity. You can redefine the function to exist at a hole, but you can't do that with an asymptote.
So let's underline 2 key words, non-removable versus a removable discontinuity. Let's reiterate that's a hole, and the vertical asymptote will be the non-removable. So go ahead and find the vertical asymptote and the hole for the next one with the neighbor. Tap on your neighbor, please. Work together.
When the bottom's like 1,
What happened again?
when the bottom's like 1,
Do I have any more variables on the bottom? It'll be none. Because the vertical asymptotes are denoted by x equals, and when that disappears, there aren't any. So we have no vertical asymptote. Do we have a hole though? What's another phrase for the hole? Removable discontinuity. Very good. Continuity. At x equals how many?
3.
Ooh,
Negative 3.
-3. It's the one that you've crossed that you need to solve for x. All right, for my third one, it says to find the vertical asymptote and the hole at x equals 2. Okay, let's go ahead and factor this out. Do I have difference of 2 squares? Yes? Okay, so we have x minus 2, x plus 2. And then on the bottom, give me the 2 magic numbers.
5 and
-2?
negative 2.
What else? 5, very good. So this is going to justify this part right here. When I cross this out, did my hole really exist at x equals 2?
Yeah.
Yep. So let's first write out the vertical asymptote. Is that x is equal to -5? And then we have our hole, and what's another term for that?
Removable discontinuity.
Very good. Removable discontinuity. discontinuity at x equals 2.
I'm already calling it RD.
You got a nickname for it?
Let me finish recording. All right, last page. It should be 2 because when I solve for x, what would that give us? Positive 2, right? All right, let's move on to the back. And this is going to be more of like a review from pre-cal. If y'all remember the limit, not the limit, the limit with the horizontal asymptote. Ben, go ahead and read that one real quick.
Is that me?
Mm-hmm.
Horizontal asymptotes are also known as limits at infinity. There are 3 cases for determining horizontal asymptotes. This is all associated with end behavior.
All right, so our 3 cases are, y'all remember the phrase low over high?
Yeah.
What equals what? Low over high? 0 equals y, if you remember. If you're like, oh no, I'm just gonna just reiterate. Y'all remember high over low? What was the phrase on that one? Slant we go,
It's a no.
okay? And then when it's the same, y'all remember something called the coefficient game maybe? So let's apply what that means. Low over high basically means when I circle the highest power of the x and the highest degree of the x on the bottom, do I really have higher degree on the bottom than the top? So that's low over high means 0 equals y, 0. Mm-hmm.
What about the logo and like those ones?
I don't recall that.
You don't?
Remind me later, okay? And then let's do the high over low. When I circle the highest degree and highest degree on the bottom, we have high over low, and the phrase was slant we go, and slant is always infinity or negative infinity. In this case, it's going to be infinity because they're both positive. And then the last one, circle the highest degree. Do we see that we have the same degree on that one? And on the same degree, when I cancel out the x squared and x squared, I have remaining 2/3.
Is that for everything that's same? Everything that's same is that third?
Mm-hmm. So let's look for all the ones that are actually the same. Would 4 be the same?
Yes.
Okay, let's go ahead and circle them. When I circle the highest power, the top and the bottom is the same. And when I eliminate them, that's going to give me 3 over 9. And we can simplify that, right? 1/3. Okay, anything else that's the same? Okay, which one's the same on the second row?
E, because x minus cosine was x and x.
Mm-hmm. Okay, how about we start with this one?
Okay.
When I square root the square, isn't that just x by itself?
Yes.
So I'm going to reiterate. That's 1x over 1x. When I cross off the x's, I get 1. For e, someone said e is one of them, and that is true. Just so you know, the cosine of x is going to be a distraction because it's an oscillating function. When it's oscillating, there's not a limit. And we talked about that on 1.1 or 1.2. So that would be x over x is also 1. Okay, now let's go on to b then. On b, when I circle the highest powers, this is low over high. What equals y? 0 equals y. Okay, I'm going to go ahead and write a second problem on C after we go over this one. So we know we have high over low, slant we go. So that's going to be infinity because it's going to go slant in a positive direction. So let's write a different scenario. If this question were to have said, limit as x approaches the infinity of negative 5x squared over the x. Which direction is that going to go? It's going to go down. So what kind of infinity is this one? Negative infinity. All right. And then what is our distraction on f? Okay. So if I circle the highest power, I know the highest power in this case really doesn't have an x. So is this high over low or low over high?
Low over high.
Low over high. So what equals y? 0 equals y. So So on number 9, if you are tempted to cross off sine of 2x, it might or might not be okay for a certain reason. For this one, while we're going to the infinity, well, I guess we can go ahead and ignore this part. If you want to go ahead and ignore this part and write 0x, go for it. So we have 0x over 1x. So when I cross off the x's, what do I get? Okay, so let's write out 0 over 1. And is 0 over 1 undefined or 0? 0. Okay, on the very bottom, I'm going to look at. Yes, ma'am.
For C, if the negative is on X, would it also be?
On C. If the negative is on x, then it'll be positive. Because we have double negative, it'll cross out.
No, if you take the negative 5
If I take the negative 5,
to X,
and then 5 is still positive, it'll still be negative. Okay? Okay, let's go ahead and read the last portion, and let's see if that's even needed. Nope, and then that's pretty much good.